The broadcast is now starting. All attendees are in listen-only mode.
Well, good morning, good afternoon, good evening, wherever you are in the world. Welcome to the DB2Night show. This is episode number 211. I'm your host, Scott Hayes, an IBM Gold Consultant and IBM Champion. Today our special guest is Pavel Sustr. Did I pronounce the last name correctly, Pavel?
Yeah, pretty much.
How do you pronounce it, sir?
So it's a German name, so it should be pronounced as Schuster, S-C-H-U-S-T-R.
Okay, we just took a few letters out for convenience. Schuster.
Right.
And you're a senior manager at the IBM Canada Lab. What are you involved in up there at the lab?
Yeah, I'm currently managing the problem determination, OSS, and STMM team. I've had some experience managing other teams. Things definitely change here in Canada, so I've managed a bunch of kernel teams over the years. I'm still an active developer of DB2, so I still contribute design, code, architecture to the main product.
That's funny. See, it's been a while since I've done this. I just noticed the title's wrong. This is DB2 LUW, problem determination, favorite tricks. That's funny. Okay, that's what we call a real-time update. There we go. Tell us, so you've been with IBM for a while. Tell us about some of your personal interests. Little secrets that the DB2 community might not know.
Okay, personal interests. Well, I've been with IBM for 18 years, and all of those 18 years I've spent with DB2. So I guess my personal interest is DB2. I would hate to come to work and not to love what I do, so obviously I must love what I do. But honestly, I do like problem determination. I started presenting about 10 years ago. I believe it was IDoug that allowed me to travel the world and talk to people, talk to users. Always thrilled to hear from our users, especially when things don't work. So my personal interest is in deep dive troubleshooting, low level disassembly, all the stuff that nobody else wants to do. I really love to do. So that would be me.
That's cool. So it sounds like the ideal Christmas present for you would be a puzzle to put together, the puzzle with 1,000 pieces. You're a problem solver.
You're a mind reader because I did get a puzzle.
Well, very good. All right. We've got people are arriving to the show. That's great. Let's carry on. DB2Night show is a show for the DB2 community. It's your show. Follow us on Twitter. Mention DB2Night show and That should be your Twitter ID. I thought I had all this updated last night. Maybe some gremlins got on my computer overnight. There we go. Mention Pavel if you do any tweeting, so it comes to his attention. That's also a great way to be able to follow up with Pavel if you want. Hit his Twitter ID. And we have a LinkedIn group. Join us in that group. And these are the show disclaimers. There we go. Copyright 2019, DBI, all that stuff. We're recording. Mind your manners. Blah, blah, blah. All rights reserved. Okay, we don't need to read that. So today we're going to have a few quick announcements. We're going to get into the favorite problem determination tricks, studio audience polls, and then we'll wrap up like we always do. Upcoming events that you should know about. DBI Software is having another one of its webinars on Friday, the 22nd of February, 1 p.m. Central, 2 p.m. Eastern. Find that at dbisoftware.com/events.php. You want to look for that. DBI gives $10 Amazon gift cards to webinar attendees, and you'll get to learn how easy monitoring and tuning DB2 LUW can be. Some upcoming shows. On the distributed database side, on the 22nd of February, DB2 LUW SQL tuning, detect, fix, and prevent problems. Klaus Brandt is coming back. He gave us a great show last November. That was the DB2 Perfect Server. 29th of March, we've got Paul Bird from the IBM Canada Lab talking about DB2 LUW native encryption. On the 12th of April, we're going to have our annual All About IDUG show. On the 24th of May, this is exciting. You're hearing this now. First, breaking news, non-fake breaking news. 24th of May, we're going to have Roger Kelly from the IBM Canada Lab is going to have some breaking news for us, so you won't want to miss that. And on the 21st of June, that'll be the last show of our 10th season, Pavel Sustr is going to come back, and he's got a 3-hour DB2 problem determination class that he teaches, and we're going to do a special 3-hour show as the grand finale of our 10th season. That'll be amazing. We'll get that on the show schedule soon so you can start registering. On the mainframe side, I know on the 15th of February, we've got data masking for DB2 ZOS. And Martin, if he's in the audience, I don't see him. I was going to ask him about other upcoming shows. I know he's got things planned and in the works, so we'll have more shows over there too. Hopefully we have a slide on IDUG. No, not yet. Congratulations to Hobie Lowe with Fiserv in Concord, North Carolina. Hobie was in our audience for show number 210. The DB2 LUW fight is on. Indexes versus prefetch. That was with Martin Hubel as our guest. Hobie was in the audience, completed the survey after the show, and lucky him, his name came out of the hat, and we'll get a $25 Amazon.com gift certificate out to him soon. And that's also a reminder that when today's show ends, look for the survey, post-show survey to pop up. Complete that, and your name will go into the hat as a potential opportunity to win a gift card. Giggle of the day. This is kind of funny, but this is kind of how confusing things can be when you're faced with problems and you don't know how to handle them. This seemed apropos for today's DB2Night show topic. We'll get some guidance from Pavel. You've got a truck that says do not follow and another truck that says keep left, meaning I don't know what to do here. That's just funny. So now we should be putting Pavel on, but another event that the community should be aware of is IDUG this year is in Charlotte, North Carolina. It's the first week of June 2nd through 6th, Charlotte, North Carolina. That's going to be a great conference. IDUG always is. Lots of great technical sessions. And, of course, you'll be able to learn a lot about that conference on our All About IDUG show in April. Pavel, let's make you the presenter and start letting everybody in the DB2 world know about problem determination. Make presenter, click this button. You get a button on your side, and we'll see your screen. There's your screen. Go to slideshow mode. There it is. Looking good, man.
Excellent. Thank you very much, Scott. I appreciate the introduction. Once again, warm greetings from a little bit cold Toronto. It's about -7 degrees Celsius over here, which is considered warm for this kind of season. I hope you're somewhere cozy and warm, and I hope that you're looking forward to this presentation as much as I'm looking forward to it. I really am looking forward to it. I appreciate your time. I believe there's 167 people registered for this talk. So first of all, thank you very much for your time, for being here with us, and for attending this presentation. Now, before we start, a few technical comments. If you have a burning question, you can just resist to postpone, and if it's something quick, you're more than welcome to ask during the presentation. I believe Scott will convey it to me. However, for longer discussions, it might be a better idea to postpone them until the end of the presentation. Hopefully we'll have some time. Or alternatively, I can give you my business phone number. We can just chat afterwards. You can actually look it up online, as with every other IBMer. There's no data privacy protection here. So feel free to contact me. I really love to meet people, but above all, I like to hear, as I said, from our users. I like to hear about their user experience with the product and, change whatever is within my powers to change. So please come to me if you see me presenting at IDUG. Please come forward, say hi to me. Don't be shy. I'm usually the shy one, so really don't be afraid to talk to me. And with that said, let's start.
Right
so
on.
Those of you
that is the advantage of people attending the live show, is they can ask questions via the GoToWebinar question tool, and we'll be monitoring those and either inject them or save them to the end. So
excellent.
Here we go.
Okay, so I usually make at least one Canadian reference in all of my presentations. So here's my reference. It's right on the first slide, the word favorite. So that's how we spell it in Canada. So Scott, kudos to you for trying to fix that, but no, thank you. You used the US spelling. Okay, so this presentation is going to be about my favorite problem determination tricks. This is a new presentation that I only created a few months ago, and I've only presented it once at IDUG. It was last November in Malta. Okay, moving on to the next page. Here's the agenda. It's actually when I first looked at the agenda, it was a little bit different. And I said, oh man, what are you doing? This is not really safe for business. So this is a toned down version of the agenda. But if you're watching the presentation somewhere at home, perhaps with your kids, please rest assured it's a clean presentation. Okay, there's nothing incorrect in here, hopefully.
So it's rated.
Let's start with
it's rated PG then. Parental guidance.
I'm not sure which rating I should be. Yeah. Let's put it that way.
In the US, it's PG.
Okay.
It's not R-rated or X-rated.
Okay, so the first slide, I just want to give you a little bit of an introduction on the kernel anatomy of the DB2 engine. So we have a lot of lines of code. We have many components. So each line of code in DB2 belongs to a larger scope that we call a component. So on the right-hand side, you will see a picture that's just the engine. It's none of the CLI or JDBC stuff. It's just the engine, and you can probably see how complex and how complicated the engine is. So, starting from the top, we see the unit that actually processes your query. So if you type, select star from customers, We will need to run it through a language processor, we'll run it through the optimizer, and then we'll break it down to individual runtime components, which you can see in the middle of the picture. And again, you'll see multiple components over here on the runtime. And eventually, when we know what we're doing, we're going to the lowest layers, being the buffer pool management component. That's where I spent probably most of my career here as a developer. So it's the buffer pool services, which underneath goes to the operating system, and your data is fetched back to the engine, back to the runtime, and back to the user. So you can imagine this is a fairly complex engine. It's a fairly complex machine. Learning a single component is hard. It's a matter of multiple years. Learning multiple components is a lifetime effort. Learning most components, not too many people can do that, and I'm happy that I know some people who can. Kerry Romanova, being our chief architect, is one of them, and it's really great to be around such people. If you happen to be at her presentation or at IDAC and see her presentation or see her presenting, I definitely recommend that you go and attend. When you look at individual routine names in DB2, we need to know this because later on we'll be referring to routine names quite frequently. There's a certain logic in how we name our routines. Typically, we have a prefix. In this case, it would be SQL or SQLE. And then we have a meaningful name that follows this prefix. Now, the first thing that I'd like to mention is that the SQL prefix is a legacy abbreviation that is not necessarily related to the SQL language itself. It basically means SQL, this is the engine, SQL processing engine. So you can think about it as a kernel component. The prefix is not always there. Sometimes, especially with Blue, with newer code, we just omit the prefix and we don't use the SQL prefix anymore. But most of the time, you will see the prefix there. In this case, we are looking at a component SQLE and SQLE, and you will see a reference at the end of the presentation of all the most favorite components. SQLE means process model. So just to summarize this slide, what we're looking at is a process model routine called calculate DB heaps. Obviously, calculate DB heaps probably means that we're doing some memory calculations, possibly during the database startup. So my point is to reveal to you that just by looking at the routine name, you can take some educated guesses. You can figure out what the routine might be doing. Function names are often a very good string to search for when it comes to APARs, diagnostic messages, DB2 Trace, and so on and so forth. The next thing that we need to go over before we get into details is return codes. So a return code or an error code is a number that usually gets mapped to a message, and it explains the status of a specific result for a specific software application. So DB2 return codes can be found in many places. The most popular place would be the DB2 diagnostic log, DB2 diag.log, but we can also find return codes in notification log, DB2 Trace, command line, so on and so forth. We try to do our best to accompany every numeric code with the corresponding user-friendly message. Most of the time it's in English, but when it comes to components such as CLP or CLI, they can be translated into your own national language. However, there are some examples, and I can give you an example from my recent experience, where the message is not there. I was looking at a Java log file, it was a Java trace file that came from a client, and it's beyond our control what Java does. And unfortunately, in this case, whoever wrote that component that returned the error only caught or captured the numeric code, but they didn't bother capturing any additional information. So it was not clear to me or to anyone what that return code meant and what exactly was going on in DB2. So the next slide gives you a little trick. That's my first trick that I'd like to share with you. Whenever you see a return code that's either hex or decimal, you can translate this number to the corresponding message. We have a tool called DB2 Diak, and if you use DB2 Diak RC followed by the code that you want to translate, it will spit out a screen full of information. But the most important piece of information, and you will see this on the next slide, is the translation of that return code into its message. If you happen to be working with pure scale and you're looking at a return code returned by the CF, cluster facility or cache facility, that's a different software component. That's not exactly DB2. It's still maintained by IBM, but it's not something that we have control over. So they have their own return codes. So for that case, you will use DB2 Diak CFRC. On the next slide, we will see an example of DB2 Diak RC. Now, this is a little bit shortened version of what you will actually see. Once you download the presentation, especially the PDF format, you will see the speaker notes have a little bit more detail on the message. But when you look at the fundamental information that's on this slide, so I have a hex number 87OF0016, and I just type it into or run it through DB2 Diak RC, and later on, halfway through the page, you will see the identifier SQLO share, which translates to this description: file sharing violation. Okay.
Sharing is caring.
That's right. Now, the return code has a certain logic. So it's really a sequence of bytes, and there are some groups of bytes that have meanings. I should probably call it a bitmap. So, a certain part of the return code is so-called ZRC class, which is, warning, error, whatever type of message this can relate to. The second bit sequence corresponds to the component returning the error. So in this case, we have SQLO, which translates to operating system services. And you could have noticed that on the previous slide, or maybe in the speaker's note. And finally, we have the return code, which is the actual error number that's returned by that component. Now, why am I telling you this? The fundamental message on this slide is the component part, SQLO. So imagine that what we saw on the previous slide, SQLO share. A sharing violation is reported by a low-level component such as operating system services. Now, this error bubbles up to the calling component, being the buffer pool services, for example. But buffer pool services will translate that code to something that the buffer pool services understand. And then they will pass it on. And then eventually it gets to the user, and there might be multiple translations of this code. So from component A to B to C to D until it bubbles up to the user. And eventually the user will see a message, hey, this is not a sharing violation. It's just that, I can't access a disk or something like that. It'll get translated to the SQL message, which should be the most generic way to describe that problem. So the point of this slide, or of this little talk, is to make you understand that a component gets translated and changed along the way to its user. Okay. Let's talk about DB2 Trace a little bit. So many of you have used DB2 Trace. Typically, you will use it when requested by DB2 support, when requested by IBM. Inside DB2 Trace, it's like any other trace that you can think of, OS trace, S trace, D trace on Sun Solaris. It's basically a sequence of calls and names of routines. So the code flow that was used within that trace, the data that's being manipulated at each point as the trace progresses. And if you choose to do so, then you can also see the time elapsed in each function. Okay, so that would be the typical use of DB2 Trace. But I have my favorite tricks, and it's not just for the code flow that you can use DB2 Trace. And let me share these tricks with you. First of all, how to enable DB2 Trace. The most obvious, the most frequent invocation would be DB2 Trace on, followed by some arguments that specify the buffer size if you're tracing into memory. And then if you choose the -t option, it means that you also want to see timestamps in the trace. I'm going to pause here for a second because the -t option is non-default, but many times, especially when you're investigating performance problems, it's critical. If you don't get timestamps in the trace, you can't measure how much a certain function call took. And measuring is knowing. And in performance problem determination, this is a critical piece of information. So I just want to emphasize that -t option. Many times it's neglected, it's ignored, or maybe not even well known to the public community. You can also trace specific components if you know which components are after. So in this case, I'm trying to trace SQLB, which is buffer pool services, and SQLD, which is data management services. So I'm only tracing the lowest layers in DB2. I'm probably dealing with a file system, maybe OS issue that's happening at the lowest level, and I don't need to see any of the optimizer stuff or runtime or sections or packages, any of the high-level stuff. So I'm only tracing the lowest level components in this case. You can also trace specific applications, so you will see examples of -app handle or -app ID, so up to 16 app handles or up to 12 application IDs. So DB2 Trace will follow all the children forked off the main process, and it'll just do everything automatically on the behalf of the application. Anything that's associated with the application, it could be multiple agents and multiple EDUs, engine dispatchable units, anything will be traced automatically for that application. Another popular option is tracing into a file, so -f dump file -t. So it's a counterpart to -l, so you can choose either L memory or F file. F file obviously will create a lot of data in your file system. You can really create tens of gigs within seconds or within a very short time. It can flood your file system, and it will also slow down your engine significantly. So it'll slow down DB2 significantly. Whereas the memory option is easier when it comes to the performance degradation, but since we're using a limited size memory buffer, the buffer will wrap. So once we run out of space, we'll start writing to the beginning of the buffer, and we only retain the most recent items in the trace if you use -l, or if you use -i, we only retain the initial items in the trace. We'll never write beyond like anything newer. Once we run out of buffer, we'll just stop tracing. Okay, verification of traces on DB2 Trace INF. And once you've enabled trace, then there's the usual no-brainer options. You have to dump the trace and create format the output file. So we have the FLW and FMT options that will format the trace in two ways. Why do we have two ways to format the trace? Here's an example of a trace flow. So a trace flow starts with an ID. It's a random number. I shouldn't say random. It's a number. It's just a sequence in the trace. So we start every trace with number 1 and end it with whatever number we can get to. So in this case, we're at trace entry 308.996, and we have a function entry for EDU37, and the name is DB2 agent. The exit from that function is at the end 317046. So this is when the function was called. This is when the function exited. And this is what happened in between. So SQLP parallel recovery was called by process escort request. And then SQLP parallel recovery exited with RC return code EMP map info not found. And then process escort request exited as well. So this is the fundamental visualization of the flow of what happened in your trace. Now, you need to understand that since we have multiple EDUs running in the instance or in the engine in parallel, the numbers that are associated in the trace flow can have, the sequence might be broken. There can be holes in the sequence. Now, why is that so? Well, for example, at 308.986, we have that EDU 37, but the next one, 87, like 308.987, the CPU will switch its context to the next EDU, for example, a prefetcher or a page cleaner, and give the prefetcher or the page cleaner a little bit of the CPU time. So in that case, that guy is the next guy to have the next ID in the trace. So because of this context switching, there will be holes in the FLW. Okay, the other way to format the trace, a so-called SMT file, is purely sequential. So it starts with 1 and it ends with, whenever the trace ended. So we will have similar information, entry point and exit points from each function, but they will be perfectly ordered by time in the order of operations as they happened in DB2. So the sequence will not be broken, but what will be broken is the EDU ID or PID. So you will be seeing a switch from one EDU to another EDU within a very short time frame. Okay. The FMT format also has a big advantage when you're looking at the actual data that's produced by each DB2 function. So when you want to investigate data produced by each function, you usually look at the FMT, not the FLW file. Also, when timestamps are present, each entry will have the beginning timestamp, like the entry point, and the end timestamp. This is not the best example because we have no timestamp in this particular on this particular slide, but you will see them on the subsequent slides. Okay, now now that we've enabled trace, here's my first trick to share with you. DB2 Trace FLW-T, and this is the dump that you had created. And this is the output file, trace.flw. So I'm formatting that file using FLW-T. What does that give me? It gives me the time spent per EDU. So, for example, in this case, we have EDU 26, which is DB2 prefetcher, and we can see the flow of its operations, how it goes down. So we're opening a file, getting a file handle, finding a slot in the file handle table and something internal. Now opening its container file. Now we're reading from the container file. This is the fundamental low-level read v that happens at the OS level, and we're exiting from the read. This is an excellent source of information if you're looking for performance degradation or a little bit of some glitches in your performance. Because when you examine this associated flow, especially when you look at these timestamps, what you need to do is look for holes or gaps. Is there a significant gap between the current timestamp and the next timestamp? In this particular example, you will see that the third entry from the bottom starts at 13.6444, and the next one, second one from the bottom, is at 13.64535. So there's a gap here, and this is the gap. This is exactly how long it took DB2 to read one page or one extent of data from the operating system. So now you can see, yeah, it took me about, 100 milliseconds. sorry, no, actually less than that. Yeah, about 1 point something millisecond to read from the from my file system. Now, this example is taken from my MacBook Pro with the latest SSD disk, so you can see that these disks are fairly quick. I mean, this read is fairly. It's almost hard to notice that we read something from the disk, but in many cases you will see maybe 1 second, not for read, but for something that's happening in your EDU, and this is a huge source of information. You can identify, you know what, between these points, especially if you can guess the name of the or the meaning of the function associated with it. This is a huge source of information.
So Pavel,
another trick.
The time scale on your output there, that was in seconds. So it's 13
yes.
point something seconds.
Correct. Yes, this is in seconds.
Very good.
Mm-hmm. Okay. Another trick is a so-called performance trace. It's DB2 Trace on -perf count -t. Okay. It's basically a profiler for DB2. If you know what a profiler means or what it does in the operating system or elsewhere, it's exactly the same thing for DB2. So just to explain or elaborate, a profiler typically takes a software package and it examines the frequency of function calls and the time spent, usually a cumulative time for each function. So it would be the number of executions and the total time spent in that function. So that's profiling. Now, DB2 profiling is exactly the same thing, but we only focus on DB2 processes. We don't care about anything else running in your environment. So when you enable DB2 Trace on -perf count -d, you will see a profile for DB2, and you just follow these little commands, these little tricks. Basically, I'm just dumping the output file and doing DB2 Trace perf FMT, and then I'm sorting that output file using a regular Unix sort. That's based on the second column, so based on the time spent. The net result is that I will have a table of the longest running calls in DB2 in a descending order. So the function on top, 1 execution of sklrr exec immd, execute immediate, took about 15 seconds. Then underneath you have 1 execution of sklrr execute immediate, again that's a different wrapper, and 1 execution of sklri section invoke, 15 seconds. And then we have about 500,000 of executions of row insert. So all of this information can give you a rough idea about whether your DB2 instance is doing a lot of I/O or whether there is a contention on the network. Where is it that DB2 is spending most of its time? This is a perfect high-level table that can give you an idea of what's happening in DB2. Just to speak to this specific example, all I did was, I think I did an insert, just 1 insert command. That's why we have only 1 execution of execute immediate. So 1 command, but that insert was to populate a table with 500,000 rows. And that's exactly what you see down below. So it took about 10 seconds to populate the table with these many rows. And what really matters is that the SQLD row insert calls were really reasonable in this case. There were, I mean, if you divide, you know, 500,000 divided by 10 seconds, that's pretty much on par with your expectations where the performance should be. But in many cases, it's not, right? So this is just a simple example of how you can interpret this data. Moving on, one of my favorite tools is called analyzetrace. It's coming soon. It has not been released yet, but you can ask me for a copy in the meantime. We are working on consolidating all of our PD tools and maybe making them available to you end users in a much better way, not just by giving you or shipping them in every fix spec, in every release. We're really thinking about how to make this more dynamic, how to make more frequent updates to these tools. And I suspect that this is one of the tools that we will probably make available to you in a better form very soon. Okay. So there's a tool called analyzetrace, but the point of whether or not it's released or not, it doesn't really matter, because the point is that the tool will take your flow file, trace.flw, and you can write something similar on your spare time if you want, and it just calculates the deltas between the current line and the next line, essentially. So if I can show you on the next slide, I did mention DB2 profiling on the previous slide. This is a profiling per EDU. So not just per instance or per engine, but this tool will take a trace and it will isolate each individual EDUs from the trace, and it'll give you a table, again, sorted by time, which you can examine to determine what exactly is happening in that EDU and how much time the EDU is spending and where. So in this particular case, I'm looking at 7 executions of SQL JC receive. So that's just a JDBC receive call, or I shouldn't say JDBC, but that's how the engine receives commands from the end user. And it took about 2,000 milliseconds. And then below there's parsing, connect, attach, engine init. All of that took about each call took about 851 milliseconds. Now it's important to understand that when you're going from top to the bottom, typically these calls that are on the top are the superset of everything else below. So receive is usually a superset of parse, and that's a superset of parse connect, attach, agent connect. So the lower you go, the more granular you're going. When you go to entry SQL init, which has 18 iterations, this is where your database gets activated. So what you're looking at in this particular case is the time it takes to activate the database. This EDU, just judging by the names of the routines, is doing nothing but connect or activate DB. But the activation is broken down to the individual components, and you can see that, for example, activating the DMS layer took about 400 milliseconds. Buffer pools took about 200 milliseconds to activate. This is the logger, and so on and so forth. All of that cumulative breaks down to first connect that took about 490, and then it took a bit more time to finalize the activation, and then we get to SQL JC receive, which is the top. That's going to be there as long as your connection is active. So that number is a little bit bloated. But anyway, you're looking at a broken down per EDU statistics of where the time is being spent.
Hey, Pavel, on your prior slide, it said that the tool was slurping. Is that another Canadian term, slurping?
You need to ask that question to Rajiv, who's the author of the file, and he lives in Phoenix, Arizona.
Slurping, okay. Because we have Slurpees. We have Slurpees in the United States, and that's a drink.
Okay, yeah, I think in Canada. I think that's the point. Yeah, I think that's what he meant.
All right.
All right. Excellent. I think this is my last trick for DB2 Trace. Yeah.
Is this a good time to take a break then?
Sure.
Should we do the break? Okay.
Yeah.
Okay. First thing we'll do on the break is we're going to ask our community polling questions. Keep in touch with the DB2 community. Our first polling question: what DB2 LUW versions are you currently running? 11, 10, 5, 10, 1, 9, 7, 9, 5 or earlier. Look for 80% of our audience to participate at least, or 30 seconds, whichever comes first. This is really good news. I think over the holidays, a lot of people might have updated or upgraded their DB2. Previously, we were seeing 10.5 be more widely implemented than version 11, but that's not the case today. Going once, going twice, closing the poll, sharing the results. And as everybody should be able to see, we got 76% of the DB2 community now on version 11, 64% on 10.5, 24% on 10.1, 32% on 9.7, and 7% running the oldies but the goodies. So sometimes people hang on to the older releases because their application vendors haven't updated. And so that's okay. Giddy up, move along when you can. Next question. What operating systems are you using for DB2 in production? AIX, Windows, x86, Linux, Z-Linux, Linux on Power. Historically, for the longest time, AIX was always the front runner, but recently we're seeing x86 Linux take a leadership position over AIX. And so far today, it's a horse race between Linux and AIX. If anybody else would like to vote, now's the time to do so. Going once, going twice, closing the poll, sharing the results. And how about that? x86 Linux has the lead here at 69% with 65% running AIX, 22% Windows, 19% Z-Linux. That's a real good showing for LUW on the mainframe. Way to go, guys. And 7% Linux on Power. Next polling question. We're putting DB2Night Show replays on YouTube now. Have you subscribed to our channel yet? And would you please? So let's see. Yeah, it's fun having the replays on YouTube. It's just another way to make our DB2 education available to the DB2 community. Some people like downloading the files, watch them offline. If you've got an internet connection, well, YouTube makes it easy. Definitely subscribe to the channel if you can. Once a YouTube channel reaches so many subscribers, then YouTube lets you do special things like get vanity URLs and whatnot. Going once, going twice, closing the poll, sharing the results. 87% not yet, but you'll check it out. Thank you very much. 6% have subscribed. No, I'm old school and I download the replays. 11% YouTube is prohibited at work. Yeah, we knew that would happen. That's why we still make the files available. Okay, next question. Are you using DB2 in that fluffy cloud thing? AWS cloud, IBM cloud, another cloud? Not yet. Considering in the future? No way, no how, not for us. Different possibilities there. We did have a show last June of 2018. It was a DB2 SAP AWS cloud success story. Go back and look for that replay if you haven't seen it yet. Lots of success with SAP DB2 Cloud. Okay, going once, going twice. Closing the poll, sharing the results. And 9% on an IBM cloud, 9% another cloud. 55% thinking about it, 26% say nope, not doing the fluffy thing. And I think we have one more polling question for right now. Are you using DB2 PureScale? Version 11 of DB2 made it much easier to use PureScale. And as of late, in the last year, I think adoption and interest of PureScale has been growing. Okay, people are voting. Let this go a couple more seconds. Click the mouse if you'd like to participate. Going once, going twice. Closing the poll, sharing the results. 12% of today's audience is using PureScale. 22% not yet, but evaluating or planning to do so. 67% say no, they have no need. And that's just fine. I mean, you're going to use PureScale where there's very demanding availability requirements, and maybe you get a performance boost as well. Okay, that is it for our polls right now. Today's show is sponsored by DBI Software, offering smarter tools for smarter people. That's the website. Most of you have been there if you registered for today's session. I'd like to point out that for 6 years in a row, they've been named by Database Trends and Applications magazine as a top trend-setting product. That's a great honor, 6 years in a row. As for other tools out there, we haven't seen the same recognition. Thought I'd take a quick moment to point out some of DBI PureFeet's top advantages. They have some of the lowest overhead in the tool monitoring industry. There's very meaningful trend charts with history, change history plotted on the charts so that you can actually understand the context of what you're looking at. There's advanced index benefit analysis that shows you how much benefit that you get from each index that might be recommended by the design advisor. Predictive index impact analysis takes it a step further and asks and answers the question, well, what happens if we create an index? Or what happens if we create these indexes? We can feed multiple indexes into the process. The entire workload is evaluated, and then it's computed. You know, how many statements improve, how many degrade, what are the improvements? It's really remarkable when you see a demonstration of that, and you can probably see a demonstration of that in the next DBI webinar on February 22nd. DBI focuses on relative weights and costs to help you find real root cause problems, just 2 mouse clicks. And there's also very robust and very extensible lights out alerting capabilities. You can get emails, you can take automated actions, you can feed SNMP trap alerts to Tivoli or other monitoring consoles. Very powerful lights out alerting capabilities. And with that, that's the end of the quick DBI commercial. Let's get Pavel back on. I'll make you the presenter again, Pavel.
Thank you. Yep. Okay.
Click on that button and away you go, man.
Perfect. You should be able to see my screen now.
I can.
Excellent. Perfect. Thank you so much. So the last example that has something to do with, function names and deep internals of DB2 is print call stack. DB2 Trace space print dash stack. Let's say that you have a flow file and you're only interested in how we got to a specific call in that flow file. Let's say that you're interested in entry 314032. If you use a command such as print dash stack and then the trace ID, it will display the code flow leading to that point. Okay, and with that, I'll leave it at this. You will see a similar code flow in your stack. You can compare in your stack files, you can compare whether or not you see more information in the trace. But this is the last trick that has anything to do with internal function names and the low-level internal stuff. Moving on to the next page. Surprise, surprise, DB2 Trace, but used for a completely different purpose. In this case, I think you will probably start to see the benefits of some of the DB2 Trace capabilities. We have an option to suspend DB2 at any point, any given point in time. We typically use it in our tests, so during regression and functional testing, but you can also use it yourself. You can test your HADR strategy, for example. You can simulate a hang, you can simulate a crash at a very specific point. And this is what the feature does. So DB2 Trace on -debug, and then you will specify where you want DB2 to stop, to hang, or to crash, or to basically the execution point. Now, how that execution point, how that map is constructed is very, very simple. DB2 is always there. That's the name of the product. Dot component name. You can get that from your DB2 Diak.log. Component name is often mentioned in your DB2 Diak.log. For example, if you're looking at SQLB init, it belongs to buffer pool services, and you will see the SQLB prefix everywhere around that function and in the neighborhood of that function. SQLB init is the function that you want to stop DB2 in, and .entry, .exit, this would be the entry point or exit point from that function, or you can use .number, which means probe. A probe would be a specific place in that function where you want to stop. So that's essentially what it does. I mean, you just launch this command, and you're good to go. Once DB2 stumbles upon this function SQLB in it, it'll do your action of choice. So in this particular case, we're suspending DB2, so we're creating a hang. But you can use the same functionality or a slightly different syntax to crash DB2 if you're testing, HADR or whatnot. You can sleep the instance, pause it for a number of seconds if you wish, using a very similar command. And yeah, that's about it. Maybe the question is, well, once I've suspended DB2, how do I get out of that? It's actually in the speaker's notes, so please refer to that. But there's a DB2 Trace change-resume command, or DB2 Trace off, which will disable tracing altogether, and DB2 will go back to normal.
Resume, that's resume in U.S. English.
Oh, okay. Sorry, that was my bad.
And you said there's like a sleep function, right? So you could put a sleep on that. So there's actually a way then to get DB2 to run slowly. Yep.
Every time, for example, every time you stumble upon SQLB in it, you can pause for 1 second. So that simulates a slowdown in B in it. So yeah, it's great for educational purposes. You want to learn whether or test yourself whether you're capable of, handling performance problems or hangs. That's a great way to simulate a slow system.
That's great.
The next neat trick is use DB2 Trace to execute a callout script. What is a callout script? A callout script is nothing but a text shell script. It's a bunch of commands that resides somewhere in SQLib under /bin. And you can actually use DB2 Trace to execute this batch of commands every time DB2 hits the specific function. So just like in the previous example, you can use DB2 Trace -debug, and then the -db2 cos option. And every time we hit, that seems like a little bug on my slides, that debug option should be followed by the same point as on the previous slide. So DB2 SQLB init.entry. Okay, sorry about that. I'm going to fix that next. But basically, every time we hit this B init entry, instead of pausing or crashing or hanging, we'll execute that callout script. You can modify that callout script. You will copy, because you don't have, by default, you don't have access to the bin directory. So you have to copy the callout script from bin to ADM. If there's a copy in ADM, it will take precedence. It'll be used first, or it'll be used, period. So you copy the script DB2 cos to ADM, and in ADM you have DB2 instance permissions to modify anything under ADM. So you locate the DB2 Trace section and add your commands. From my personal experience, I have used this technique a few times. One of the notable reference was when I was dealing with running out of file system handles reported by a customer. It was a very short-lived event. Every time it happened, it wouldn't survive or it wouldn't last more than 2 seconds. So we basically used DB2 Trace to set up a trap in the function that was reporting running out of file system handles, and I executed a callout script, and I inserted some LSOF commands into the callout script, and we were able to capture the moment when the problem was happening, and we realized or determined that the root cause was actually outside of DB2. It was, I believe it was a Solaris bug or something like that, or something was consuming file handles and it should not have been. Here's an example, but I'm going to go through this a little bit faster because we don't have that much time. And it's basically what I've summarized on the previous slide. This is a live example of what happens and what you will see in the DB2 Diak.log and what you will see on the screen. So the important one is that you will see a message in the Diak.log, and then on the screen you will see a trace point caught, and that's about it. There's another way, and now we're leaving DB2 Trace behind. There's another way to execute a callout script. It's called DB2 PDCFG. The syntax is slightly different. So for those of you who are not familiar with the DB2 PDCFG tool, DB2 PDCFG is a spin-off from DB2 PD, which is our diagnostic tool that has direct access to the engine. DB2 PD does read-only operations. DB2 PDCFG needs different authorities, different permissions or privileges, and it can also be used to modify the behavior of the engine. So that's why we have DB2 PDCFG as a spin-off from DB2 PD. We don't want everything under one functionality or one command. So here's the syntax: -catch diag string. So unlike DB2 Trace that binds to a function, internal function somewhere in DB2 source code, this method binds to a message in DB2 Diak.log. There's a catch here. The message that we're examining or trying to capture must be located in the message section of the diagnostic log entry. So it's not just anywhere. We don't do a grep or text search throughout the entire entry. We only look specifically at the message section, subsection of a DB2 Diak.log entry, nowhere else. Okay, so that's one catch. Why do we have two techniques to do the same or seemingly the same thing? The reasons are explained in the table below. So you would want to use DB2 Trace when a specific routine and /probe is executed, or when a diagnostic message is simply not there, or when one routine produces multiple messages and you don't actually care whether it's message A, message B, message C. All you need to do, all you need to know is, have we hit that particular point in DB2? That's all you need to know. So for that, you would use DB2 Trace. However, if you only care about the diagnostic message, you don't know which function produces that message, or you don't care, then you would use DB2 PDCFG. Or when you simply don't know which routine produces that message, or you're not sure, but you know what the text looks like. So that's also when you would use DB2 PDCFG. Or when multiple routines produce the same message. I mean, it's not very frequent, but it might happen, especially if the message is very short. And you don't care whether it's routine A, routine B, routine C, you just care about the message. So that's when you would use DB2 PDCFG. Here's an example. Again, I'm going to go a little bit faster through this. So here's a message that you will see in DB2 Diak.log catalog cache size. And I'm trying to configure DB2 PDCFG to capture this message, okay, catalog cache size. So here's what I do. DB2 PDCFG catch, diag string equals catalog cache size. It can be a substring of the message, actually. Then I do connect to sample, and in DB2 Diak.log, I see, oh, the message has just appeared. Dump the stack trace. And also run the DB2 cost script. Okay, so that's what's going to happen on your screen and in your DB2 Diak.log. Okay, that concludes the first part of my tricks. The second part is a very quick log problem determination. So you have a connection to the database, something is hanging, the connection is hanging, the database is slower than usual, and you're guessing that it has something to do with logs. Well, that's your wild guess. You want to eliminate logs as the root cause or confirm it as the root cause. What can you do? There's a command called, not very known, well-known command called db2 logs. So if you combine these two options together, you will see information on all logs that are currently used by the database, no matter if they're being waited on or not. And wlogs will also produce information for transaction logs that are being waited on. So there's a contention somewhere. An example is right here. To connect to a database, and using the previous technique from the previous slides, I'm stopping DB2 at SPLD, DNS map, and read, which I know from experience that this is a function that reads from the table space. So I'm stopping DB2 while it has a table space file open, and while it's doing an active read from that table space. Okay, I'm suspending DB2 indefinitely. Now, from another session, I do from the same session actually. I can do select on start just to invoke that table space read, trigger that table space read. And from another session, and this will hang. From another session, I will connect to sample and do list tables that also hangs. I open up the third session and I do db2 sample-logs-wlogs. In the first section, you'll see all logs that are currently being used by the database. The first point of information that you want to look at is the mode, X. So when you see something being held exclusively, that means X means exclusive. That's usually the first shortcut to the log information. And also another shortcut is that if you have a W somewhere in the status column, that means that the log is being waited on. And that's always very good read. So you basically want to examine the W's in this status column and the X's in the mode column. Okay.
Hey, Pavel. Some of the attendees and myself were hearing a lot of noise or static. It's just developed out of line. I don't know if there's something that's gone wonky with your internet connection or something. Do you have a phone nearby? Could you join with your telephone?
Yeah, I just put on my headphones. Is this better?
Oh, you just put on your headphones.
Now I did, yes. Before I was using just the regular. Is this any better or is this the same?
That's actually better. So whatever you did, don't do that.
Yeah. Okay, I'll just keep the headphones on. I might be yelling a little bit too much because now I can't hear myself, but hopefully that's not a problem.
Yeah, you sound better now when you put those headphones on. Then
okay,
that's when the static started. So
okay,
glad we got that cleared up.
Mm-hmm.
Don't want to do that headphone thing anymore.
Okay, thanks for telling me.
Sure. Thanks for clearing it up.
No problem. So we have this G's and W's as I mentioned, but we also have the other section. It's called the WL logs section here. So it will go straight to these two suspects, and it'll tell you, yeah, you have two logs, and one of them is a plan log being held in X, and it's being granted to application handle 8. And then you have another guy, application handle 38, that's also looking for the plan log in X, and it's the same log, and it's waiting, right? So that's now you can see a log wait very clearly. You don't need to go through the entire list. If you're curious about the log name, and this is just something that's also mentioned in the speaker notes, you can actually format this log name using mon format log name function. It will display some human-friendly information about what that log is for and what exactly it means. Okay, so that's just on the side. But anyways, the point is that W logs will go straight to the holders and waiters of the log. Let's say that you don't have a locking problem, but there's still a slowdown or a full hang. Now, in this particular case, you want to look below. You want to look much lower into the lowest layer called latches, DB2 latches. Okay, DB2 latches are almost like logs, but this is the lowest synchronization component in DB2. That's how we, basically a semaphore or some kind of a critical section. That's how we synchronize EDUs, how we implement logs underneath, and that's the fundamental, most elementary unit in DB2 that's used to synchronize things. So a latch. So we have no log holders, we have no waiters. The 1-minute tip is do DB2 PD-latches. Okay, it'll give you a quick overview of, similar to the W logs, it'll give you a quick overview of latches and whether they're being waited on. You use that only if you don't care about the root cause very much, only if you want to confirm, yeah, there's a latch wait. The reason why you don't want to use DB2 PD latches for problem determination, like deeper problem determination, is that you will not get any call stack files or any of the deep internal DB2 data that can be sent to the development, and they will tell you, yeah, that's exactly what's happening in DB2. Okay, so that's just very basic information. If you do care about the root cause, my tip, 1-second tip, is DB2 PD-stack all or DB2 FODC-hang basic. And each of these methods is usually followed by analyzestack-L, and I'm going to talk about that on the next slide. It gives you method number 2 gives you more detail, and it's probably harder to read, but that's what you use for root cause analysis. Okay, so here's a scenario. Connecting to sample and stopping DB2 in pool table new pool, which is while I'm creating a table space. Okay. Now I'm going to do create table space TS1, and obviously it hangs because of that trace commit. I'm doing a session 2 connected to sample. This table spaces also hangs. I do DB2 PD-latches, and here's an example. It goes straight to the latch in green. So when you see that the holder, and especially the waiter column, is not null, so it's not 0, that means that this is a latch that's being contended on. So there is a holder of the latch, and there's a waiter of this on the same latch. And the latch is called pool table latch, which is not really important. It could be anything. I mean, you can guess that it has something to do with the table space, because pool in DB2's terminology is actually a table space. So it's some kind of a table space latch that's being contended on, or that's being requested. And this is pretty good for root cause analysis already, because you can search this string on Google, or in if you go to IBM and search for known A parse, you can type this into the search engine and see if you can come up with anything. If you do the more complicated, more convoluted method, that would be method number 2. You can do DB2 PD-stack all, and this is the kind of output that you will see. And after that, I did tell you that we have a tool called analyzestack. The tool currently resides under sqlib/pd. It's a shipped tool. And if you run that tool with these options, where -i stands for the directory where your stack files are located, and -l stands for, hey, load all of these stack files and see if there's any dead latch that you can find in these stack files. So that's what the L option is for. So when you see a message that says something latch wait detected, it could be 1, 2, 3, 4, you're done. You can send this to IBM and they will have a look for you, or you can have a look at the data yourself and Google around. But this is exactly what you're looking for. This is a confirmation that, yes, there is a dead latch present on your database. So again, it's very simple. DB2 PD-stack all, then you run this tool with -l. If you see this red message, you're done. You know that there's a dead latch. If you want to dig deeper and investigate what that message is all about, you will look at the holder information, and you will look at the waiter information. You'll see the stacks. You'll see the EDU IDs. You can take excerpts from those stacks and Google, again, search for known APARs, known problems, as you wish. The other method, aside from DB2 PD-latches, is DB2 FODC. It's called it stands for First Occurrence Data Capture. This is my preferred way of collecting information, and I always tell customers, you know what, when you're not sure, always use DB2 FODC. The reason being is that we, as IBM, are familiar with the data. We know how the data is structured, we know what to look for, we know how the scripts are written, and we actually own the tool. So we are responsible for analyzing and understanding of all the specific technicalities of the product or of the tool. If you create your own script that does, you know, a bunch of commands, DB2 PD-latches, and one get this and one get that, it's also great, but we're not too familiar with what you did, and you may have made a mistake and this and that. So it's better to use our IBM's tools. If you don't like what's in the callout script that's used by DB2 FODC, you can change it. So you can modify it, you can add things, hopefully not remove, but add things, and that will also help us, because at least we know that you're using our standard technology. So here's DB2 FODC-hang option, and I usually use basic if it's a hang, because it won't connect to the database and it won't cause an additional hang. If you find, and that's a frequent question, if you find DB2 FODC too slow, and yeah, it does take about 13 to 15 minutes to complete, but if this is too much, if this is too long for you, then you can modify the tool. You can modify the callout script that's executed by DB2 FODC. Again, copy DB2 cause_hang from bin to ADM so that you have permissions to modify it. Look for no wait equals off and change it to no wait equals on, and then execute DB2 FODC as usual, so DB2 FODC-hang basic. Now, if you do that, you will essentially remove all waits between iterations, because typically we collect data in multiple iterations, iteration 1 and iteration 2, and then we try to look at the deltas between these two time frames. But if you don't care about these iterations, and many times actually we don't care, and if you want this tool to complete as fast as possible, then do this little no wait trick and you're good to go. Here's an example of what the actual execution looks like after you've modified the script. So you started OS configuration info at 7:03:40 p.m. and it finished at 7:04:17. So that's like, you know, 30 seconds later, something like that. So this is beautiful. It's much better than 15 minutes or 20 minutes. So if you're under stress, you know, you need to bring the system online as soon as possible. That's one of the tricks that I would recommend. Okay, we're reaching the end of the presentation. So the last few tricks are related to a table space. A frequently asked question is, hey, what's in my table space? What's the layout? Where are my extents? What extents are owned by what objects? And where are the holes, the free extents in my table space? What's holding the high water mark? The documentation says that you can't really determine the high water mark yourself. I apologize for this statement. I will open a defect to fix that, hopefully soon. The documentation is not correct in the sense. You can use db2dart/dhwm display high water mark, and that command will not only give you the high water mark, but it'll give you the perfect text-based table space map. So let me show you an example. So I'm doing a display high water mark on my database test, and this is the list of my extents. I have 268, 0 to 268 extents allocated in the table space. Now the first few extents, as usual, they're allocated by some system objects. You can tell because there's a high number, like 65,000 and higher. That's usually a system object ID. But anyways, this is the extent ID. This is the owning object. That's the type of the extent that you're looking at. When you go further down to the high water mark, extent 268 is being owned by object 5, and 0 means it's a regular data object. So table data extent. There you go. Bingo. You have a table space map. So that's another trick. We're reaching the end. So one of the last tricks that I want to mention is DB2 Sleep. It's a registry environment, DB2 registry variable that is typically used by our test teams. Let's say that you are dealing with an outage. Your system is producing FODC trap or FODC panic, and then it goes down. You don't want the system to go down. You want the system to freeze at that moment when that FODC outage is happening. And that's when you can use DB2 Sleep. Use it with caution, obviously, because when you run into an FODC outage, FODC trap, instead of shutting down the instance and then you can restart the instance will actually hang. It'll freeze while the FODC data is being created. Why is this a good way or a good thing to have? Well, sometimes, it's not very often, but sometimes the FODC underscore trap directory or FODC panic directory doesn't contain the last little bit of information that you want. It's a very edge case scenario where, you know, it's the stack files and everything, all of the diagnostic information is there, but you would still love to see a little bit extra, a little bit more. If you freeze your instance in this way, especially if it's a reproducible problem, then while it's frozen, you can still run DB2 PD commands against it, right? So anything that requires a database connection like monget and this and that, it will not work. But DB2 commands will still work. And that's actually a great gold mine for information. Once you're done, you can do DB2 PD CFG-wake-up instance, and the instance will wake up back to normal. There's a little example on DB2 Sleep. So this is what you do: DB2 stop, DB2 start, EDUs, and I'm just picking an EDU, the main system, DB2 CCP EDU, and I'm sending two signal 11s to the EDU. There is a reason why I'm sending two, but we don't have time to elaborate on this. Let me just tell you that you have to execute the kill command twice. Now you will see that the FODC trap directory has been created, but if you do DB2 PD EDUs, you will still see that the instance is alive. It's still online, it's still active. It has not gone down yet. So now you can execute additional DB2 PD commands against the sleeping instance. This concludes my presentation. I have a few backup slides, and I'll only mention one sentence for each slide. So here's the list of popular DB2 components and their prefixes.
Very nice.
Here's the list of important routines when you're looking at hangs. If you see a stack file with one of these routines on the stack, you should not ignore it. And these routines are the counterpart of the previous slides, or of the previous slide. You should always ignore, or most of the time you will ignore EDUs that are stuck in these functions. So you can just skip that. Here are deadly signals and exceptions in DB2 and when they can get created, what they mean, how they affect the instance. So all of these will kill your instance, all of these signals and Windows exceptions. Here's the list of abort signals. So this is a suicide, instance panic. DB2 has found a problem that it cannot recover from and needs to commit a suicide. So these are the signal numbers that will be used. And that's about it. That's all I have. Before we wrap up, there's one ask for each one of you. There's a Stack Overflow survey that Scott will kindly put into the replay session. The Stack Overflow survey has some database questions. What is your favorite database? What kind of databases have you used recently, and when? So we, as a database team here in the lab, we're very interested in the popular opinion out there. I mean, how popular is DB2? How frequently do people use that? So please kindly, if you find time, fill out that Stack Overflow survey. Let us know. Let us know what you're using, what you're not using, and I would really appreciate that time spent on this. With that, Scott, are there any questions that we need to answer?
Well, I've been fielding them as the show's been going along, not anything specifically to your presentation. We had the little audio issue that we got fixed, and people are excited about your PDF handout. I'm sure that's in my email, and I'll get it on the replay blog. Let me take our steps to wrap up. And
okay, so maybe I'll just, before you do so, I think this is probably my last opportunity. I just want to thank everybody once again for attending this, and I also want to thank you, Scott, personally, for doing a great job in tweeting about this seminar and making it public, and I really appreciate the opportunity of being here, and I really hope hope that the subsequent presentation that I'm doing in June is a success, and I'm really looking forward to it. So thank you once again.
Yeah, that's going to be great, and I'm not surprised by the results of this polling question, asking people if they've learned anything today, and you really gave a lot of great information today. It's kind of a teaser for the 3-hour class in June. This is awesome. Going once, going twice, closing the poll, sharing the results with everybody. There we go. 100% of today's audience learned something from it. So that's really great.
Thank you.
That's really
I'm humbled.
So we'll remind everybody to please complete the post-show survey, and we'll be giving away a $25 Amazon gift card. And thank you, all of the attendees, for joining us today. Thank you, Pavel, for your great presentation. Really fantastic stuff. Today's show was sponsored by DBI Software, smarter tools for smarter people. You can reach the team at sales.team@dbisoftware.com. Give them a phone call. DBI is your trusted partner for breakthrough DB2 performance solutions that deliver invaluable results for organizations having the most demanding requirements and discriminating preferences. And with that, takes us to the conclusion of the end of episode number 211. Pavel, I hope you have a great weekend.
Thank you, Scott, and you as well.
And I hope everyone in our audience has a fabulous weekend as well. If it's cold where you are, try to stay warm. Okay. Have a good one. Bye for now.
Bye, everyone.